Hello everybody and welcome to the final lecture perhaps of this course. The reason I say that is that I've covered now more or less everything I wanted to cover on the course, all the different material for the different aspects of machine vision. So I thought what I'd do now is go into a little bit into what you can do in terms of revision for the exam and a few comments perhaps about the assignment. So if I just go on to have a quick look at what we got here. We go to the lecture notes section, of course, in the on Blackboard for the module. Then the first lecture, just looking at it here, is where I just tried to set the scene for machine vision. You remember this? I won't go through all these in detail. I just thought I'd mention one or two. And this was just where we started from, explaining what machine vision or computer vision is, and what we're trying to do with the 2D, because the 3D, of course, then deep learning is a kind of niche for our lab, as you know. And that's that paper I presented, going through that. And that's a poster, which actually was the organisers. That didn't come out so well in that. It was better than that when it was printed out. And the organisers thought it was a good poster, so it went okay. And talking about what you can do in terms of further reading. So I won't go through all this, but I think it's all pretty self-explanatory. Basics of machine vision, really, what we're trying to do. Why the sense is important. I mean, it's the most important sense, I would say, followed perhaps by tactile, which is very important when you're trying to manipulate things with robots, really. But yeah, so this is an extremely important sense, of course. And then went on to machine, vision assistant, and then ultimately onto LabVIEW, wasn't it really? So that was a nice introduction, hopefully. So there's the poster paper I put on there, and yeah, that's how it was printed out actually on the wall at the conference. Very self-explanatory, I think, really. Yeah, so it was an application, I thought quite a nice application of vision and deep learning. And the paper, of course, I put that on there as well. It's a paper that was presented in the proceedings for the SPI conference, Optics and Photonics in San Diego. I tried to make it quite concise about explaining the advantages of what we were trying to do, really, I guess. Okay, then, so we're going on the other, lectures, of course, into more of an introduction to machine vision, and there I went and put up the previous year's paper, which was presented in the Vegas conference, on three-dimensional face analysis, of course, the work we did principally for the London Underground. And I thought that was quite a nice paper, because we have done a lot of work on that, starting really in a strong way in 2007, with the work we did with Imperial with General Dynamics. And that rig still works in the lab, actually. But yeah, so that's the paper. I put that on there. Maybe, yeah. Nice little paper, really. Not bad. I say so myself. It's okay. And we're going on to the other things that I mentioned. Other applications. Of course, it's more like a deep learning ability to recognise things there. A lot of industrial applications are fairly prosaic, looking at stones in the presence of fruit and so on conveyor belts. And then there's going to the basics of machine vision, and some new slides I generated for that, and talking about resolution and so on. And again, this is one or two of these images I took out of the Image and Vision Handbook. When it comes, by the way, to the assignment, which I'll talk more about in a minute, you don't want to really, I wouldn't really recommend lifting images like I did for this because I'm more interested in what your ideas are. I'm not interested in what's available in the handbook, because I can go look for myself. But I'm more interested in what your ideas about how to configure things and so on. So I kind of don't mind if you put sketches in. That's okay, as long as you get across what you're trying to do. And this goes on to deep learning and so on. Anyway, so what I tried to do with the course, you might have noticed, I started off giving a couple of lectures, introducing the subject of machine vision, and then talking about applications and what you can do and different powerful techniques. What I also did, of course, was I talked about LabVIEW in alternate sessions, really, because I really wanted to talk about what you can do with LabVIEW. And of course, you need a bit of LabVIEW for the assignment, so I want to get you guys into it, sort of in a gentle way. So it was Vision Assistant, which then generates some LabVIEW down the bottom of the screen, and then getting into what you can do with LabVIEW in the IMAX image processing toolbox, which is pretty good. Then again, went back to things like the machine vision process, talking about that, and alternating again with what you could do. Of course, the idea of virtual instruments, which I was talking about last time a lot, The idea being that you can generate an instrument with LabVIEW, this is what they call them, virtual instruments, the programs, because you can simulate a real physical instrument by means of the computer, basically, to put it in a nutshell, can't you? So that's your idea of virtual instrument. And then talking a lot about LabVIEW and how it works, carrying on with introduction to machine vision. And what I tried to do in some of the lectures, of course, was give a little bit of a few hints about useful techniques you can use in LabVIEW. So, as you know, it's a G programming language. So the idea of auto-indexing and shift registers are not terribly obvious things. So I did spend a little bit of time emphasizing those, really, to get people's that idea across. And then going on about image processing and pattern recognition, because I wanted to talk in the course a lot about classical image processing and pattern recognition, because it's still quite a big area. I mean, everybody's talking about, when you go to a conference, everybody's talking about deep learning, machine learning. But that's not all there is. I mean, and again, if you had a problem in industry that you wanted to solve, and you could solve it by classical techniques, such as using the LabVIEW functions, then that's what you do. You don't want to make things overly complicated and difficult. If there's a simple solution, that's what you go for. And that's why lighting is so important, because that can help you highlight features of interest and thereby reduce the processing complexity of the program. You don't need so much cleverness in the program because you're getting more useful information immediately out with the image. So careful structure of the lighting can really help you setting up a good machine vision application. So then talking about applications, then of course I went on in a bit more detail about aerospace applications, looking for damage on aircraft, even quite a good one, and a whole range of applications, of course, with drones. I even saw a video someone sent me yesterday of a load of drones flying around in synchronization and creating all sorts of patterns like Santa Claus and so on. And it's amazing what you can do with precision control of drones, actually. Most of the interesting applications I was thinking of course, though, were in sort of aerospace, all sorts of delivery of packages, Amazon and so on, and then the agri-tech one, of course, that's a big area for us, agri-tech, and other applications, really. EasyJet's getting into it, as we say there, on there. And carrying on with applications of machine vision. I talked a bit about the assignment. So what you want to do then, in preparing for the lecture, is to go through all this again, obviously, go through all these lecture notes, and read around all the stuff I've tried to put on there. But of course, that's not everything, because I don't want you to just reproduce what I put onto the internet, onto Blackboard. It's also about your ideas. It's more about your ideas about, I'm interested in what you think about things as well. So in addition to this, if you can read around as much as possible on the internet and in books you can get hold of, in the Imaging and Vision Handbook, which I got for you, of course, I think it's a really good resource, especially for the assignment, which I'll talk more about in a minute. But just reading around that's how to prepare for the exam, is to read all this, of course, read around the subject, and then have a look at the past papers I put on there to see the kind of style of questions I'm likely to ask. That will give you a good background, really. Sometimes people ask me if I put model answers on. Well, I don't, because I can't for the kind of questions I'm asking. I'm not interested in you guys reproducing my particular answer for a problem. It's not the kind of questions where you can do that. So I'm really interested in your ideas for solutions, in particular industrial machine vision problems, really. So then going on with the lectures, talking about 3D and 2D techniques that are widely used. We're using them right now. I just started a project for Innovate UK, looking at accurately measuring people's joints during exercises, and using a combination of 3D and 2D again. That's a funded project. It's a very intensive one that's running for 3 months, leading on to other projects. But I mean, the techniques we use in the lab a lot, of course, laser triangulation, where you rig a laser lab at an angle to a conveyor belt, say, and then you recover the data from, say, whatever's going along the conveyor belt. It's very, very commonly used in industry, of course. Stereo triangulation being another sort of a very commonly used technique, because it's very good because it has long range, and it's a one-shot technique. You just take 2 images simultaneously. Unlike the thing bouncing along a conveyor, there can be errors due to it moving around as it goes. But with stereo, it's a one-shot technique. It's a little complicated in trying to solve the correspondence problem, which I think I talked about a few weeks ago. And that can be a problem if you want to do lots of processing on the fly with it, want to do it in real time. But it is nevertheless a very useful technique. And of course, photometric stereo is the other one that we use a lot in the lab, which I talked about quite a lot, which is definitely worth being aware of, because that's a major technique for us. We've used it over a whole range of sectors and applications in medicine, looking at skin condition to looking at faces, all sorts of other things like surface inspection for tiles, the tile inspection machines, or polished stone, all sorts of things. So it's definitely worth having a look at photometric stereo. So as I say, then the two niche areas we've got in the lab, of course, are the 3D machine vision and the deep learning. So that's why I did spend quite a lot of time talking about convolutional neural networks, which a couple of lectures there. And I used to keep buying, I seemed like I was buying a top-end PC with a fancy GPU every other week until recently. So we have got some pretty good computer facility. That's what you need, of course, if you're trying to do some deep learning. You need a lot of data generally. There are some techniques to help minimize the amount of data you need. You might remember I mentioned them, like transfer learning and data augmentation. So it's definitely worth having a look at those techniques, getting familiar with them. I mean, the paper, for example, on the weed detection, there's quite a lot of discussion of that. So anyway, you usually need a lot of data, and you do usually need a lot of processing power. But the processing power, of course, is only for the training. Once you train the deep network, you could then consult it quickly and easily. So then I spent a session talking about the Centre for Machine Vision, going on about what's going on in our centre in some detail. And then I put the past paper on, where I tried to talk through this past paper, which I hope will be useful for your revision purposes. I put some example questions on, as well, in addition to that, perhaps, just give you a bit of further background, but some further illustration. But so that's what we're looking at then for the lectures, by and large. That's what I've been talking about over recent weeks. Now, if I want to have a quick talk, so I talk a little bit there about how to prepare for the exam. Okay, so we're looking at an online exam, and you'll get full instructions, but you've got 3 hours to do the exam, normally 24-hour window but you'll get full instructions about how to do the exam, but it'll be online. Now, the other thing I want to talk about is the assignments, of course, and this assignment is the one you've been asked to submit, of course. So a couple of images of the pipe, and there we have the assignment handout. So that's the deadline. Make sure you submit it by the deadline, of course. That's very, very important. And follow the instructions. Now, the handout is pretty self-explanatory, I think, really. People ask me questions sometimes, but a lot of it's actually, their answers actually in the handout, turns out. A little bit of introduction. You've got the sample images. And yeah, so the maximum length of the report is 2,500 words. And what we need to do is submit a report and this LabVIEW virtual instrument, of course. You want to make the LabVIEW instrument robust, get something working and keep it backed up in case problems occur. You can always go back to one that works. If you're trying to improve things, make it a little bit more slick, keep one that's working in the background all the time. And make it easy for the examiner, I would recommend. Just have one VI that you can run from. Try to make it easy to run, make it reliant, robust and easy to run. Because otherwise, if we had to spend a half an hour trying to get it running before we start marking it, it's not the best start for a marking session. So yeah, so this is pretty self-explanatory. There are details required in the report. I put a bit of emphasis on this because people sometimes tend to do a lot of effort on the program, on the LabVIEW program, but not bother so much with the report. And that's not good because quite a lot of the marks are for the report. I'll put the marking scheme on there if it's not on there, so you've got access to that. Now, yeah, so what do you have to put in the report? Well, it says what's here. Include a contents, introduction, conclusion, bibliography, and include screen captures LabVIEW. Say how it works. Don't include general material. I'm interested in what you did, why you did it, how you got it working, why you chose that approach for getting the program working, that architecture for the program. I don't want a load of stuff from LabVIEW help. It's just wasting everybody's time, isn't it, really? And include images that show results of processing the images of the hose using your VI. And then an essay in addition to that. The essay required in the report is a discussion of factors that would influence the design of an effective and practical demonstration system for detection and measurement of air-to-air refueling hose damage. Examples of practical problems that the vision system would need to address include changes in background light and the need to inspect all around the hose hose all around its circumference, including your discussion details of how you would recommend configuring a system able to address such factors. For example, identify suitable lighting, cameras, include schematics to show how you would arrange and configure the equipment. So I think that's pretty clear, isn't it, really? I'm interested in the problems that would occur if you actually tried to install this thing on an aircraft to do this. And I won't go through them because I don't want to tell you how to answer the question, but you can imagine, as it says there, changes in background light. That's quite interesting. That could happen quite a lot depending on the applications when you're running this thing. But how could you overcome that? You can think of some ways of overcoming that. It can be simple, it can be more complex, but I'm interested in your ideas. Inspect all around the hose. Well, with obviously one camera, you can't inspect all around the hose, so you're probably going to include a diagram with more than one camera, and how you do it would be interesting for me to see. Okay, part 2, the benefits of a 3D vision approach in this application. The VR you developed only measures 2D characteristics by analysing a conventional 2D image of the hose. However, researchers studied this problem and identified a number of potential drawbacks of only employing such a 2D approach, and found that also employing a 3D approach could provide additional useful benefits. Identify 2 such benefits, and for each benefit, identify a 3D vision technique that might be suitable for achieving it. In each case, briefly describe how the technique works and how the benefit will be attained, i.e. the advantage it offers over 2D approach. Use diagrams to help with explanations, identify any problems that might expect to occur, and suggest possible solutions. It's very important that your discussion relates to the hose application rather than just being a general discussion. So yeah, you don't want to keep talking generally about what's going on in machine vision. You don't want to do that at all. You want to talk about the hose application and what you can do in relation to that. So what's the advantage of 3D over 2D? And I won't go into it here because obviously I want you to come up with it, but you know, what benefits does it provide? Identify 2 benefits, and for each benefit, identify a vision system, a 3D technique that's useful for achieving it, and then briefly describe how it works. But what you want to do is describe how the benefit's going to be attained. You know, you identify a 3D technique, you reckon it's got some benefit, explain how it provides that benefit, and for 2 different techniques. And there's a few hints there on the LabVIEW programming there as well. I think I just put onto Blackboard recently a few further hints that might be useful for how to approach that. And of course, you want to talk to Abdul's available in the first semester, so he's great to talk to him and to give you as much help with that. So that's it really. And that the idea then, as you know, I guess that's something we did weeks ago. I think it was the 3rd tutorial or something like that. And yeah, so you created an image in iMac, LabVIEW. You read in a file into the image using this dialog box setup, and then you displayed it. Of course, we should in reality destroy the image after we finished as well. But this was something very simple that I got you guys to. I think I even went through it in one of the videos. And I don't know about you, but I find it helps to have something simple to work with, and then you can build on it and keep building it up incrementally until you've got your solution to your assignment. But that's what I do. Keep building on it, keep saving all the time, so if something goes wrong, you go back to the one that worked. But the fact is, with G programming, everything's a lot simpler than it would be if you were trying to do it in C or something like that. So, and then you want to, when you've got the assignment fully ready, you want to submit it online, and the guidance is there. Now, another important thing I got at the top, of course, it's important. I'm sure you're aware of problems of plagiarism, but it's important that your assignment submission entirely composes your own work. Detection of plagiarism or student collusion and the systems they use for that can result in a mark of 0. So you make sure that you submit your own work, and don't. Collusion is copying, it's bad. Plagiarism is using other people's work and not referencing it, which is not what you want to do. So you want to get it all nice and sorted out with your own work and submit a nice little submission. I've got to say that in previous years I've been very impressed with the effort people have put into this, and some very nice solutions and very nice programs they've come up with for getting this working. So so I think that should be okay for you. So I hope that's been of some use, just covering what you can and can't do with well, not what we can and can't do, what's best to do, how to approach the revision and the assignment. As I say, if there's any major issues, you can always drop me an email and we'll try and sort them out. The important thing, of course, is to get this, not leave everything to the last minute, to time it all out, to get yourself to pace yourself on it all, and to get a nice solution in good time so it's not a last minute panic. So that's it. All I can say then is all the best with the with the exam and with the assignment submission. I think this is more or less the last lecture in the course. So I just want to say thanks very much for taking the course. I hope it's been useful. And I'm sure I might see some of you guys around. But in the meantime, have a great Christmas and Happy New Year.